Hello, young people. Part 4, maybe? External energy. We're in Unit 2, Lesson 1. This is video number 4, external energy. So, like we said, almost all of the energy, 99.99% of the energy here at the surface of the Earth, comes from the sun. And it gets here as radiation. We already covered that. Another thing that we already covered, but we should say again, is the input and output of energy from the Earth's surface is roughly equal at all times if we're looking at the Earth as a whole system. So let's talk about how the inputs and outputs of energy work for the Earth as a whole system, the external energy. So it starts off coming from the sun, and we have radiation, electromagnetic radiation. And we have high energy radiation, ultraviolet. That's what gives you sunburns. And we got visible light, a little bit lower energy. And we got infrared. In other words, heat, which is even lower energy than visible light. Okay? So that's what's coming to us. And all of that solar radiation, one of two things is going to happen to it. It's either going to be absorbed or it's going to be reflected. That's it. If it's absorbed, that's another way of saying it is transferred onto the Earth. If it is reflected, it's sent right back out into space. And so this is a nice, simple, tidy way to think about it. And I hate to be the bearer of bad news, but in reality, it's actually more complicated than that. In most cases, it's actually a combination of absorption and reflection. A good way to think of this, imagine I go to my kitchen and I fill up a cup of water. Fill up a cup of water all the way to the brim. And I go to carry that cup of water with me to the couch. And partway to the couch, I slosh a little bit of water. You know, my hand's not steady and some water spills out, gets on the floor. When I get to the couch, I have less water in my cup, but that doesn't mean there's less water. It just means that that spot on the floor between the sink and the couch is now wet. That's what I mean. The analogy there is that the cup of water, the water is the energy, and some of it might get absorbed and some of it might get reflected, but the same amount of energy is, energy can't be created or destroyed. So it's got to go somewhere. A really useful word for us that we're going to use a lot. Better get this one in your notes and learn what it means because you're going to have to use it. Albedo. Albedo. A-L-B-E-D-O. Albedo. And albedo is a word that basically means the amount of energy to be reflected by something. So think of a picture of the Earth from space. What colors are in your mind? There's beautiful blue oceans, maybe some brown where the continents are, and some white where the clouds are, and some bright white where the polar ice caps are. Right? Everybody's got that picture in your head, right? Which of those colors is going to reflect the most sunlight? It's going to be the white, right? It's the white clouds and the white ice. So, white has the highest albedo. It reflects the most solar energy back away from our planet. And basically it's just tied to color, more or less. You got these dark blue oceans. Well, if you bombard a dark blue ocean with a bunch of sunlight, it's going to absorb more of that light. It's not going to reflect as much because that dark colors absorb more energy. Um, so that's we've got energy coming in. Some of it's being absorbed, some of it's being reflected. Um, and what is reflected is sent back out into space. What is absorbed is transferred into different Earth systems. Now, one last little thing I want you to think about with albedo, um, the amount of energy that is reflected. Albedo plays a big role in feedbacks. Feedbacks are an important part of science and systems and the way system parts interact. Think about it like this. If you have a giant sheet of ice, sea ice, floating in the ocean, and you shine a bunch of sunlight on that, it's going to reflect most of that sunlight back. And everything that it reflects back is not staying at the surface. Well, if we start to melt that big chunk of ice, then we have less surface area with that high albedo of the ice, and we have more surface area with the low albedo of the ocean water. Okay, so now what happens when we put the same amount of sunlight on there? The ocean water absorbs more of it. Absorbs more of that energy, and that energy turns into heat. What does the heat do? The heat makes the ice melt faster, which means even less high albedo ice and even more low albedo ocean to absorb even more heat, to warm up the water more, to melt the ice faster. That's a feedback. It's a positive feedback loop. Not positive because it's good. It's positive because it keeps pushing itself. It's a system and it keeps pushing itself in one direction. A negative feedback loop is something that pushes back towards equilibrium. So albedo plays a big role in feedbacks. All right. Next up is the distribution of sunlight. We're nearly to the end of this thing. See you next time.